So far we have read in class 11th that these substances are made up of atoms. Now the next topic of the importance is to measure the atomic mass, to know the atomic mass of atoms. Now how we can know? First of all, we have to know that atom is so small, it cannot be isolated. It cannot be isolated and weighed. So we cannot determine the atomic mass. First, the problem is atom is small, it cannot be isolated and weighed. Now, second is if we take a large quantity of atoms, large quantity of a substance, and count the number of atoms in it. If we take large quantity of a substance and if we weigh it, then if we count the number of atoms, we can know the mass of a single atom. But atoms cannot be counted. Atoms cannot be counted because atoms are small, they cannot be isolated and they cannot be counted. So the problem to know to determine the mass, it was solved by Avogadro. Avogadro has given the law which you have read, that equal volumes of all gases under similar conditions of temperature and pressure, under similar conditions of temperature and pressure, contain equal number of molecules. This is the definition of law, statement of the law, Avogadro's law. Now, this means if we take two equal volumes of the gas A and B, and if we weigh them, then the ratio, this law means if we take equal volumes of two gases, equal volumes of two gases, then ratio of their masses will be equal to ratio of the masses of single molecules. For example, when equal volumes of hydrogen and oxygen gases were taken, hydrogen gas and oxygen gas equal volumes were taken, and the ratio was found into out of 1:16. That means oxygen gas is 16 times heavier than hydrogen gas. Or we can say, since hydrogen is diatomic and oxygen is also diatomic, we can say oxygen atom is 16 times heavier than hydrogen atom. So this was the comparison of oxygen and hydrogen. In the beginning, the masses of all atoms were calculated, or they were determined by comparing the gas with hydrogen. So atomic mass was defined at that time. We can define the atomic mass when we take hydrogen into consideration as a standard. When the comparative we study, when the comparative in case of comparative, we take the hydrogen as a standard. So then atomic mass of an element, of an atom of an element is the number which indicates how many times an atom of an element is heavier than hydrogen, an atom of hydrogen. That is, if we write atomic mass, A is equal to mass of one atom of an element divided by mass of one atom of hydrogen. This was comparing, and we take the relative mass here. We compare the mass of one atom with the mass of one atom of hydrogen. In the beginning, hydrogen was used, and in 1958, oxygen was used as a standard. That means now the atomic mass of the elements was determined by taking by comparing with the oxygen atom, and it was now at that time. So atomic mass is equal to mass of one atom of an element over 1/16 part mass of one atom of oxygen, or we can write it is mass of one atom of an element where mass of one atom of oxygen into 16 here. So now the question is, why oxygen was used? You know, oxygen, with oxygen all the elements combine and form oxides. So this was the reason why oxygen was used. First reason is, with oxygen forms compounds with almost every element. Oxygen forms compounds with every element, with almost every element. Number second, when hydrogen was used, the mass came to fraction. Atomic mass came fractional. ये point होगा नहीं आ रहा था, fractional आ रहा था. So by using oxygen as standard, here mass of hydrogen is equal to 1.008, that of sodium is equal to 22.991, and that of sulfur is 20, it is 30, 2.066. This was the mass of when we compared with the oxygen. Now in 1961, carbon 12 isotope was taken as standard. In 1961, International Union of Chemistry accepted carbon 12 as a standard. So now the atomic mass of elements was compared with carbon 12 isotope. So here atomic mass is equal to, we can define as atomic mass can be defined as a number which indicates number of times mass of one atom of an element is heavier than 1/12 part of mass of one atom of carbon. Carbon 12. So this was related to atomic mass because we compare the mass of atom with the carbon 12 isotope. So we can write here atomic mass is equal to atomic mass is right. Atomic mass A is equal to mass of one atom of an element over 1/12 part of mass of one atom of carbon 12. That is equal to mass of one atom of an element with mass of one atom of carbon 12 into 12. So this is atomic mass. This is the relative atomic mass. Now 1/12 part of mass of carbon 12 is known as AMU, atomic mass unit. 1/12 part of mass of carbon 12 atom is known as AMU. So mass of carbon 12 is equal to mass AMU is equal to 1.996 into 10 raised power minus 24 is 1.996 10 raised power 23 grams divided by 12 or 1.996 into 10 raised power minus 26 kilograms over 12. That comes to be 1.66 into 10 raised power minus 24 grams or 1.66 into 10 raised power minus 27 kilograms. This is the value of AMU. So you know relative mass is equal to, now relative mass relative atomic mass is equal to absolute mass in AMU, atomic mass units, divided by 1 AMU, or we can say absolute mass is equal to relative mass into AMU, or we can say hydrogen का absolute mass is equal to relative mass है 1.008 into AMU is equal to 1.66 into 10 raised power minus 24 grams. इसी तरह ऑक्सीजन का रिलेटिव मास है, ऑक्सीजन हाइड्रोजन का ये है, ऑक्सीजन का बन गया 1.16 into 1.66 into 10 raised power minus 24 grams. This is by this way we can calculate the absolute mass of that is relative mass into AMU. Now this is the actually we take 1.006 or 1.16, this is we take, these are the average masses. So average क्यों लेते हैं? Because we take in the fractional abundance, for example chlorine consists of 2 isotopes, for example 35 and chlorine 37. So we write this 30 ratio is 3:1. So we write chlorine mass is equal to relative mass is equal to 35 into 3 plus 37 into 1 divided by 3 plus 4. 3 plus 1 is equal to 35.5. This is the average relative mass. So this is how we can determine the atomic mass of an element. Thank you.